Howdy, y'all. It's Mr. Russell. I want to try to emphasize the importance of today's lesson. So please fasten your seatbelt and let's pay attention because we're learning about molarity and concentration. So let's try to think a little bit about how clean our water is. So we have standards for what can be in our water, like what kind of lead, what kind of metals can be in our water. Um, but it's constantly being checked for its concentration. Now it's mostly water, but there's a very small part that is something else. So that something else could be maybe mercury or arsenic, barium, chromium, fluorine, mercury nitrates. Gross alpha means these kind of particles, okay? Now, they're also testing for different chloroforms and trimethyl halides and haloacetic acids, but those are different kinds of things. These are your heavy metals that we really worry about. They actually really poison us. So, guys, this is Bryan right here. This is 2010, so this is kind of old, but what they're doing is they're looking at the detected levels right here. Now, you can see the concentration here is parts per billion, parts per million. ppm is parts per million. ppb is parts per billion. All right. So it has this lower limit and an upper limit, right? Or its goal limit. Okay. So this concentration is something that we use all the time. Your water plants use this, and we will use this a lot. So it is the unit of measurement for this is called the molarity, right here. Oop. Molarity. So molarity, and we'll describe to you how scary or strong something is. Okay. So it is defined as the number of moles of solute divided by the liters of the solution. All right. It's quite simple. It's just moles over liters. Liters of the solution. So which one do you think is more scary? 0.2 or 12? 0.2 molar or 12 molar? Yes, that's how we say it. We put a capital M here, and we don't say moles, we just say molar. So 0.2 molar or 12 molar? Well, it's 12 molar, right? Obviously, you would think the higher number is going to be the higher concentration. Yes, you are correct. So in general, the more concentrated the solution is, the faster the reaction will be as well. So that actually, because you have more particles available to collide with each other, so there will be more, the frequency of collisions will increase. So if we put 0.5 moles of sodium hydroxide in 1 liters of solution, what is going to be the molarity? So there's a lot of math equations that come with this. Well, if you just take 0.5 moles and you divide by 1, really just type in your calculator 0.5 divided by 1, the answer is going to be 0.5, right? So you would end up with a 0.5 molar solution of NaOH, all right? So how many moles of KOH are in 0.5 liters of 0.1 molar KOH? Well, so we have an unknown number of moles here, and then we have 0.5 liters, and we have 0.1. Now you should be able to manipulate the math enough to know that you need to multiply both sides by 0.5 to find your number of moles, and it's going to be 0.05 moles of KOH. Now what is the molarity if we have 80 grams of NaOH in 1 liter? So if we have 80 grams, well, grams isn't very useful because we need moles over liters. So we need to change grams into moles. So I'll take grams and I'll convert it into moles right here by dividing by the molar mass. Yes, we're going to do mole calculations and the molar mass calculations. You get this from the periodic table. G stands for go to the periodic table, and we get this. Now, if you're at home trying to find out the molar mass, just Google it. Just type in NaOH molar mass, and you probably don't even have to push enter. It will pop up the molar mass for you. So very easy. You don't have to calculate it or use a periodic table. Now, just take that 2 moles that you found, divided by your 1 liter from the problem, and that's going to be 2 molar. Very simple. Now calculate the moles of a 1.25 liter solution of a 2.5 molar HCl. That's hydrochloric acid. Well, I'm going to take my unknown number of moles divided by 1.25 liters, multiplied by both sides by 1.25, and I get 3.13 moles of HCl. Now the next type of concentration, this is still a type of concentration, but one that we might use in a different way, is percent by mass. Your vinegars, like your vinegar bottle, if you look at it, it's a percent by mass of 3%. Your hydrogen peroxide is also about 3%. What they're saying is that 3% of it is vinegar, and then the other 97% is water. Well, by mass. All right, so that's basically what they're doing right here. So the equation for this, the percent mass equals the mass of the solute divided by the mass of the whole solution, which would be the mass of the solute plus the mass of the solvent. So what is the percent percent mass of NaCl in a solution where 25 grams of NaCl is dissolved in 500 grams of water? Well, if you just take 25 grams of NaCl and divide by 25 plus 500, you'll end up with 4.76%. So for example number 2, how many grams of glucose are needed to dissolve in 2,000.0 grams of water to make 2.80% glucose solution? So we have 2.80% glucose solution here, and then we have, we don't know the mass of solute here, but we do know that this is 2,000 grams of water. What you can do is, you know that we'll just put x's right here for our mass of solute, and then you'll have to solve for x. You'll first divide by 100, and then you'll actually have to move this denominator over to the right side, distribute, combine like terms, solve for x, all that good stuff. I'll explain it to you in the next video, but the answer is 57.6 grams. In the PowerPoints, I didn't really explain too much about how to actually mathematically do these, so I'll do these on pencil and paper. These are in your notes on page 6. So we talked about percent mass, which is the mass of solute divided by the mass of solute plus the mass of solvent. That's also known as the mass of solution. Right, that bottom part, right there. So a solution of sodium chloride is prepared by dissolving 12.5 grams of salt in 625 grams of water. Calculate the percent mass of the solution. So if we take 12.5 grams of salt, and that's our solute, and we take 12.5 grams, and we add it to 625 grams, that's our solvent, multiplied by 100, we get 1.96%. Now for number 2, calculate the mass of NaOH in 15% by mass solution that contains 65.5 grams of solvent. So that's asking me what mass of solute does that is required to get 15% if I have 65.5 grams of solvent. So you basically know that there's 15%, and you know that you'll have 100, and that you have x divided by x plus 65.5. And what you can do is divide both sides by 100, so that's easy. So you get 0.15, and you'll get x over x plus 65.5. Now, you guys are pretty math savvy, but you should know that you'll take the denominator here, and you'll end up moving it to the other side. So basically you're multiplying both sides by this little denominator that I've got in green. What you'll end up with is 0.15 times x plus 65.5. And then equals x, then x stays there. And then so you'll distribute that to everything, and you'll get 0.15x plus 9.83 equals x. Now remember that this is a 1, right? That's a 1x. That's an understood 1. So when we combine like terms, we're going to move this x over to the right side. So we'll subtract both sides by 0.15x. So we'll get 9.83. And so 1 minus x, 1x minus 0.15x is going to be 0.85x. So now I can isolate x very easily by dividing both sides by 0.85, and I'll get 11.56 grams of my solvent, all right, which was NaOH. And that is my answer. Our molarity, guys, I can't emphasize enough how important molarity is. So molarity is capital M, and it's our moles of solute divided by liters of solution. It must be liters. So if we calculate the molarity of a solution prepared by dissolving 85 grams of calcium sulfate in enough water to make 600 milliliters of solution, we have 85 grams of calcium sulfate. Now that's not moles, that's not liters, but we can make grams into moles pretty easily. We have 85 grams of calcium sulfate. We can convert grams into moles very easily by using the molar mass, which is 136 grams per mole. G stands for go to the periodic table. And then I'll get 0.625 moles of calcium sulfate. Well, then it makes it a simple matter of taking 0.625 moles and dividing it by my given volume. Now 600 milliliters is 0.600 liters. All you had to do is take the decimal place and move it 3 places to the left. So I'm going to make that many liters. You've got to make sure you do that. And that's an easy trick, easy habit to convert milliliters to liters. You'll do that a lot because this has to be in liters. So we get moles over liters, and then that will be 1.04 molar calcium sulfate. Capital M means molar. Now, how many grams of KOH are in 2.75 liters of 0.25 molar KOH? Oops. So, since we remember molarity is moles over liters, we know that we have 0.25 molar, and we have some X number of moles here, and we know that we have 2.75 liters. That's a simple matter of just multiplying both sides by 2.75, right? To cancel that out. Once I do that, both of those cancel out. 2.75 times 0.25 is going to be 0.6875, and that is going to be the number of moles. So basically you multiply both sides by your volume, or take your molarity and multiply by your volume, you get the number of moles. And then, so once I have the number of moles, 0.6875, we can convert moles into grams. This is honestly the backwards of what we did before. There's 56 grams per mole in KOH. You go to the periodic table for that one, and we get 38.5 grams of KOH. Number 5 asked me what volume in milliliters of 0.15 molar NaOH would contain 3 grams of NaOH. So we got 3 grams. That's useless to us. Useless. Let's convert grams into moles of NaOH, because that is NaOH. Pop quiz, the molar mass of sodium hydroxide is 40. Because I know that because I'm a nerd. All right, so 0.075 moles of NaOH. And so once I have these number of moles, now I have the molarity here. So that's 0.15 molar equals 0.075 moles of NaOH. And then my unknown is my volume, right? So my unknown is this guy down here. Now it's going to be in liters whenever I find this equation. So we'll worry about the milliliters next time. Now the only way to really get rid of this is I have to multiply by this x over here and move this x to this side. And then I'll have to divide by 0.15 and move the 0.15 to this side. Honestly, truth being told, really what you're going to do is take your you're going to take your number of moles and you're going to divide by the molarity. So you're going to end up with 0.075 divided by 0.15. That's going to equal your x. So that's going to be 0.5 liters. And really, that's going to be 500 milliliters. Yeah, with 2 sigfigs. Now, how do you know that, Mr. Russell? You can use this density. It's like density, but if you take the moles divided by the volume, moles divided by liters will give you your molarity. So moles divided by molarity will give you your liters. Liters times molarity will give you your moles. So you multiply here, and you divide here, and you divide here. So it's just like density, because remember density was mass over volume. That looks a lot like molarity is moles over liters, right? Looks the same way. All you need is that little formula. Moles, liters, molarity. All right, have a great day.